So lecture number 24, and today just I am going to finish this unit after engaging few contents of this, and on the next day hopefully I will start the unit number 4. And on yesterday I was busy and I was unable to engage your class because I was also on CL. Now this is the basic page replacement method, how we are going to replace the page during the page fault condition. So number first is the find the location of the desired page on disk. So first we will find the location on the disk, and first we will select that whether there is a availability of the free frame or not, because first we will choose the page, and as it will go to the next site, that is in the context of the physical memory, then the page will be changed as the frame. So first we will find out the free frame. So which one is free frame? Now again there are two conditions for this. If there is a free frame, use it. So if the frame is available, then how we are going to use that frame, or how can we avail that frame? If there is no free frame, use a page replacement algorithm. So now there is a need arise to use the page replacement algorithm. So there are number of page replacement algorithm, and this happens when there is a page fault, and page fault condition, whenever we will face this condition of the page fault, then the operating system will use the algorithm to replace the page. So write victim frame to disk. Then first the operating system will check which frame is the victim, that is which page is infected, or if there is a page fault, then we will check the corresponding frame number, and we will note it down what is the frame number, or which is the victim frame, okay, for the disk. Because at the end the page replacement, or whenever the operating system is going to find out the victim frame, then it will store on the disk to bring the desired page into the free frame. So if the operating system, first it will check that the free frame is available on the physical memory or not. If there is the existence of the free frame, then the desired page, it will move to the free frame. Okay, so into the free frame, update the page and frame tables. Now, after the replacement of the page into the free frame, then the operating system will update the page and frame tables, because in the frame table the operating system is going to store the frame numbers, okay, and also it has the record of the valid or invalid bit number. Okay, in the next slide we can see that we can check how the operating system is going to replace the page. Okay, so continue the process by restarting the instruction. So whenever the page fault will occur, then the operating system restart the instructions that cause the trap. So first the operating system will find out the reason why the page fault is happening there, or there is no existence of the page, that is called the page fault, and after that the process will restart. Okay, and again there is a need to write the instructions so that the operating system will be able to find out the cause of the trap. Now here there is a one note. Now you can see potentially two page transfers for page fault, increasing effective memory access time. So sometimes it happens that instead of the one page, two pages transfers together, okay, under the page fault condition. And due to the two page transfers for the page fault condition, then there is a increase in the effective memory access time. So the access time will increase or will enhance. Now this is the diagram here you can see for the page replacement. Okay, so page replacement when it occurs if there is a page fault, if there is a page fault condition. Suppose your process is executing and there is no page in the RAM, random access memory. Okay, then during that time, that condition arises that is called the page fault condition. So the process stops at that time, or if we are using the page replacement algorithm, then with the help of the page replacement algorithm, the operating system can easily replace the page on the free frame. Okay. Now here you can check the condition. This is called the page table. So this page table maintains record about the number of pages. Okay. So whenever you will write the program and as the program will execute, that is called the process, and there are several processes may execute, okay, or maybe in the queue. Then in this page table, the operating system will maintain the record, okay, about the total number of page occupied by the particular process. So here this is called the two areas, and this page table is divided here in two columns. You can see first is called the frame, okay, and second one is called the valid or invalid bit. So on the behalf of the valid or invalid bit, here you can check or reset the page table for the new page. Okay. So if the condition is valid here, valid bit or invalid bit, so the condition is here number two, you can see change to invalid. Okay. And this is reset page table for new page. So as the here, if we want to reset the page table for the new page, so whenever we are going to add or we are going to replace the page, then we have to reset the page table. Okay, then operating system will reset the page. Now here you can see we can represent this as the valid bit and I for invalid bit. So this is the page table, and page table is used to keep or maintain the record about the frame numbers, okay, frame numbers whatever we are using, and also the valid or invalid bit. Okay, and this here you can see this is called the physical memory. Okay, so physical memory, in this case we can say this is the victim means there is a page fault condition. Okay, here there is no page for a particular process, so we have to wait here, and the operating system will use the page replacement algorithm. Okay, so as the page will come here into the free frame. This is F. F is the free frame. So the page will take over the free frame, or the page will come here into the free frame. Then this is, we are going to remove the victim here. Okay. So this is called the swipe desired page in or swipe out victim page. So just we are, what we are doing here, or the operating system will send the signal for removing the victim page, swipe out victim page. Okay, means the page fault condition here. Okay, and this is swap desired page in. So this is new page is coming, and we are going to replace this. Means the operating system is going to replace this faulty page by the new page. Okay, so here reset page table for the new page, as this page will come from the secondary storage to this side to the physical memory. Okay, because the again we can restart the process, and this process will come here on the physical memory, and after that we can call this as swap desired page in and swap out victim page. So just we are removing this victim page or removing the page fault condition here. So this is called the page replacement. So how the page replacement will take place, you can check here or see here in this diagram, in this block diagram here. Again, now you can see this is the page here, page replacement. Another example here. Now this is the page frame, just we are indicating by F, and now we are here replacing, because this is replaced by 0. Okay, as we are going to reset page, this reset page table, then here the value will change. Okay, so the 0 will come here again, and again this is for the new frame. Again we can replace this also. Okay, or the process is same as you have already seen in this case. Okay, so this is victim, and just you are going to change, replacing this value. 5 6 here is numbering in the page table, and in this case you can also check here 5 6, just you are going to replace the faulty page by the new page. Okay, now, how you can evaluate with the help of the algorithm? Now you can check here, evaluate algorithm by running it on a particular string of memory references. So here we will use some string for the reference and computing the number of page faults. So first we will check or find out the condition for the page faults on that string. Okay, so we can check for a particular process that how many faulty pages are available. Okay, now the operating system also can count total number of page faults during execution of the process. Now you can see here string is just page numbers, not full addresses. So here string, just you are going to maintain the string, and it is indicating the page numbers, not full address of that process. So repeated as access to the same page does not cause a page fault. Okay, if the process is repeating for the same page, then we cannot say the page fault. Okay, now trace the memory reference for a process. So we will use a particular process, and then we can trace the memory reference. So always whenever we will use either the physical memory or the CPU memory, then we will divide the memory spaces, and each memory have some address. Okay, so these are the various memory references: 0100, 0432, 01 this, and so on. And here we are also indicating the page size. Okay, so page size is 100 bytes. So this is called the size of the page. Okay, page page size is 100 bytes. So this is the 100 bytes page. Okay, we can increase the page size of the process for whatever we are using, and this is the reference string. So it is the string which we are going to use. This is called the reference string, and we can replace this. Okay, this one is not common string. Okay, we can change the string as per need. So just we are considering the example 141616. Now in all our example, the reference string is this. So further, whatever we are going to use the examples, so we will use the reference string this. 70120304230 like and so on. Okay, so this is the reference string. So in the forthcoming examples, we will use only this string as a reference string. Now, what is the reference string? You can understand in the coming slide. Okay, but here this is the fixed size. So the page size is fixed here, 100 bytes, and the reference string is this. Now you can check here. This is the graph between the page fault versus the number of frames. So how many frames are available in the physical memory? Okay, inside the RAM, because it is divided into number of frames, number of memory blocks, that is called the number of frames. So the upper portion is reserved for the operating system, and remaining unused area is called the area for the user program. Okay, then the same user area, the operating system will divide into number of frames, that is called the free frames, till there is no allocation of that area for a particular process. Okay. Now the number of page faults for a particular process, you can here check for the process how it is taking place. So these are the number of frames, okay, and these are the number of page faults. So for a particular process. Now here you can see if the number of frames here only one. So this is only single frame. Now you can see the page fault probability is very much, very high. Okay. So as the number of frames are increasing, then the page fault condition here it is decreasing. Okay. So this is the graph between the number of page faults and number of frames. So number of frames, these are nothing but the total number of pages. Okay. So total number of pages which the operating system is going to allocate for a particular process. Okay. So the as the number of frames will increase, then page fault condition also going to reduce, also decreasing drastically. But if the number of frames are less, then the page fault here you can see the probability is very high in this case. Okay, now this is the one of the process for the page replacement, first in first out. Okay, this is called the, so there are various algorithms which we will use for the page replacement process. So first is called the first in first out FIFO algorithm. So what is the FIFO algorithm? Associates a time with each frame when the page was brought into memory. Okay, so whenever there is a need arise to browse a new page into the memory, okay, so that is we are going to remove the page fault condition. So there is a need for the new page, and the new page will come to the memory. Okay, so when a page must be replaced, the oldest one is chosen. So we can replace the page, or also we can choose the old one. Okay, if there is a existence of the old one, so we can replace that old by the new one, or if there is a no existence of any page, that is called the purely page fault condition. Okay, then we can use the demand paging. Okay, or we can call it as the pure demand paging. So under the page fault condition, we will use the condition of the demand paging. Okay, the signal will go to the operating system, and after that, the new page will be brought into the memory. Okay, so this is again the reference string which is used by the author here. This string for the reference of the memory. Okay, so in the next page, phase we will use this reference string. Now we can check the limitation. What is the limitation? A variable is initialized early and constantly used. So here also there is a need of the variable, and that will be initialized by the operating system. So here the limitation is because here we will use the valid or invalid bit. So we can also use a variable here. Okay, so this is one of the limitation for this algorithm, first in, first out, how we are going to remove the pages or how we are going to replace the pages. So how many numbers of first the operating system will count the page faults. Okay, for a particular process, that how many pages are infected. Okay, means the total number of page faults for a particular process, and after that the operating system will replace all those pages, that is called the victim pages, or the page faults conditions. It will be removed by the operating system with the help of the FIFO algorithm. So there are a number of algorithms which the operating system may use for the replacement of the new page or to remove the old one. Now here in this case you can see FIFO page replacement, first in, first out. So this is the process name which will be used for the page replacement. Now in this case, as it is mentioned, 3 frames means 3 pages can be in memory at a time. Okay, 3 frames available है means 3 pages can be in memory at a time. तो एक टाइम में आप 3 pages मेमोरी में हो सकते हैं आपके, ठीक है। 3 फ्रेम्स यूज करेंगे तो 3 पेज एक साथ आपके मेमोरी में प्रोसेस हो रहे हैं, ठीक है, 4 हैं। ओके, 2 frames means 2 pages in memory at a time, 1 frame 1 memory at a time. So the frames just is directly related to the number of pages. Okay, so 3 frames means how many pages you are going to select for a particular process. Now again, this is the same reference string which you have already seen in the preceding slides. It is mentioned in the red colored here. So this is the reference string. How they are going to use this? Now the operating system will use, here you can see 7. Okay, so this is the first page number 7. So 7 here, and again now uh, because we can use 3 pages at a time here, so this column now you can see divided into 3 rows. Okay, because we are using 3 frames here. Okay, we can also use 4 frames. Okay, then it may be divided into 4 rows. Okay, now we are using 3 frames, then here we can see 701203042. How it is, you can see here, it is going into the page frame. So 7, so first one is here 7. Again, here you can see how it is replacing. It is going first in, first out, then 7 and then 0 here. Okay, 1, then 701. Okay, then the new here frame will again restart. So the 2 will go again. Here you can see 0 1 is will remain same. Again you can see. So here you can check that 1 2 3 4. Again here you can check 6 and 4 10, and these are 5. So for a process here we are considering that in this example, for a particular process there are 15 page faults. Okay, so there are 15 page faults. Then how we are going to remove those page faults with the help of the various page replacement algorithm. Okay, so we are assuming that there are 15 page faults. So under this, how to track pages. So first, the condition is first the operating system will track the pages. So just use a FIFO queue to hold all the pages in memory. Okay, replace the page at the head, insert at tail. तो यहाँ पर आप देख सकते हैं रिप्लेस हम किस तरह से करेंगे, हेड साइड से इंसर्ट करना है हमें टेल साइड से। ओके, किस तरह से हम टेल साइड से इंसर्ट करते जाएंगे और हेड साइड से यहाँ पर रिप्लेस करते जाएंगे। तो आपका डिपेंड करेगा, सबसे पहले यहाँ पर द ऑपरेटिंग सिस्टम विल चेक दैट फॉर ए पर्टिकुलर प्रोसेस हाउ मेनी पेज फॉल्ट्स आर देयर। ओके, so if there are 1, 2 or 5, 10, 15, it will depend on the circumstances. Okay, and how with the help of the page replacement algorithm, the operating system will send the signal to overcome these types of page faults. Now another algorithm is called the optimal algorithm, again for the page replacement process. So replace page that will not be used for longest period of time. So the condition is this, for a uh, just we are going to replace the page that will not be used for a longest period of time. Okay, how do you know this? Can't read the future. Used for measuring how well your algorithm performs. So this is the optimal algorithm. This is called. So now just I am taking because the time your attendance here. Time is finishing already. Now I will engage your next uh, sixth class. Okay.
सर कंटिन्यू कर सकते हैं सर, क्योंकि गैप है सर
अच्छा
हम लोग का वैसे भी।
अच्छा अच्छा अच्छा, गैप है, ठीक है ठीक ठीक, ओके
जी सर।
ठीक है। तो नया आपका वो स्टार्ट करते हैं हम फिर। ठीक है, अभी फिर आप कनेक्ट हो जाना हमसे।
जी सर।